I'm starting where we left off at the end of part 1. The microscope and GIF setup are as before, and this is the same region of the STO bismuth ferrite iridium multilayer that I showed previously. Let's go ahead and get the spectrum image set up. First of all, start the live scan. Remember to use preview mode and not search mode. Next, make sure that the EALS and EDS buttons in the SI palette are blue, which means that these signals are active. Now click on the 2D array button to create a spectrum image region. The green box shows us where the spectrum image data will be acquired from. This region looks good. It covers all of the layers and the substrate, so I won't make any changes to the ROI position. 2 milliseconds is a good pixel time for the current microscope condition, so I won't make any changes here either. I'd like a pixel size of 5 angstroms, so I'll change the pixel size as it's currently set to a little under 5 angstroms. The total capture time and dataset size are both shown in the SI palette. The total map time is less than 2 minutes, so there's no need for drift tracking. The short total capture time is also beneficial in reducing specimen damage. For this acquisition, I'm going to use live mapping. To enable live mapping, just make sure the live map button in the SI palette is blue. To check the live map parameters, click the periodic table button in the live map row at the bottom of the SI palette to show the live map setup dialog. We can choose to display the elemental signals that will be mapped all together or separate into EALS and EDS by selecting one of the buttons at the top left of the setup dialog. It's also possible to load and save analytical setups using the buttons at the top right of the dialog. I saved an analytical setup earlier, so I'll click the Load Setup button to load my setup. The saved EALS mapping parameters are good, but I want to make some changes to the EDS setup. To make changes to the EDS mapping setup, just click on the EDS button, then select an element and choose which signal to map. Once all the changes are made, click OK to exit the live map setup, and click Capture in the SI palette to acquire the data and show the live maps. Live mapping is a great way to monitor the results in real time. This is particularly beneficial if a sample is beam sensitive, or if we need time-resolved data, like in an in-situ experiment, for example. The microscope I'm using is a Joule F200 with dual EDS detectors with a 1.6 steradian solid angle. The Continuum camera has a very high sensitivity phosphor and can run up to 2700 fps without detector binning, with close to 100% collection efficiency. The end result is very high quality signal-to-noise ratio spectra and maps over very large energy ranges, even at short exposure times. The low energy dispersion has allowed me to collect the carbon K, oxygen K, titanium K, iron L, strontium L, iridium M, platinum M, and bismuth M edges in a single spectrum. Even at just 2 milliseconds per pixel, the high energy loss maps are very high quality. The strontium L edge at 1940 eV, the iridium M edge at 2040 eV, and the bismuth M at 2580 eV. The spectrum image objects that were just acquired are linked. If I use a picker tool to extract data from one of the cubes, the software will automatically show me spectral data from all of the linked objects. This is a simple and fast way to look at the EDS and EALS data at the same time, with confidence that the spectra we are looking at originate from the same regions in the sample. That's all for part 2. To see how to acquire 4D STEM and EDS together, watch the final part of the multisignal spectrum imaging tutorial.